The last example I want to show you involving finding a matrix representation of a linear transformation is an example we've kind of seen already. We are going to take P3, which is the polynomials of degree 2 or less, to P2, which is the polynomials of degree 1 or less. And the mapping is going to take any polynomial to its derivative minus 2 times its second derivative. And the basis I want to use for P3 is written right here. And the basis I want to use for P2 is written right here. I want to find this matrix. So pause the video, write all of this stuff down. You might even try to see if you can do it on your own. And I'm going to work this problem out. Okay, so this matrix is equal to, well, we're going to take things in P3, apply L to them, and then write them in terms of this basis. So L applied to 1 in terms of this basis. Okay, so I just wrote out the entire matrix, what I need to do. So let's put these 3 basis vectors into L and see what we spit out. Okay, we're going to start with L of 1. Well, that's easy because the derivative of 1 is 0. Now let's try L of negative 2x squared minus 1. Okay, so we take the first derivative, which is negative 4x, and then we subtract 2 times the second derivative, which is just negative 4. So we get negative 4x plus 8. Okay, and then the last one is to plug in x, and that's just 1. Great. Now I need to write 0, negative 4x plus 8, and 1 in terms of this basis. Well, the first one's easy. This one is 0, x minus 1 plus 0, x plus 1. But what about negative 4x plus 8? So this is what times x minus 1 plus what times x plus 1? I need an 8. So maybe we can do a negative 4. So if I multiplied this by a 2, no. All right, since that's taking me too long, we're going to have alpha x minus 1 plus beta x plus 1 is equal to negative 4x plus 8. We're going to group the x's, so we get alpha plus beta x is equal to negative 4x, and we also get negative alpha plus beta is equal to 8. So that tells me alpha plus beta is negative 4 by getting rid of this x, because that x can't be 0. And then negative alpha plus beta is 8. Add them together. 2 beta is 4. So beta is 2. And then since alpha plus beta is negative 4, alpha plus 2 is negative 4, alpha is negative 6. So we get -6, 2, let's double check, -6x plus 2 is -4, and then we get a +6 and a +2. That works. Great. Okay, now we just need to do this last one here. Let me erase this so it's not in the way. How do I write 1 in terms of these basis vectors? So 1 is equal to, again, I can put alpha times x minus 1 plus beta times x plus 1. I need to find this alpha and this beta. So what do we get? I'm going to use a similar method here. We said that alpha plus beta times x is equal to 0x because this is 0x plus 1. And then negative alpha plus beta is equal to 1. So that tells me that alpha is negative beta. Okay. So alpha is negative beta. So then 2 beta is 1, beta is 1/2, and alpha is -1/2. All right, we've figured out what alpha and beta are. So this is 1/2, this is -1/2. You can see that the x's cancel. And then I get a +1/2 and a +1/2. Add those together, you get 1. Great. And now we can just write this matrix because this is going to be 0, 0. This is going to be -6, 2. And this is going to be -1/2, 1/2. So let's write it out. L with these bases is 0, 0, and -6, 2, and -1/2, 1/2. Okay, we're done.